Welcome to your complete guide to mastering number systems, the very backbone of mathematics. In this video, we'll explore why number systems are so essential, how they help us count, measure, and solve real-world problems, and why understanding them is crucial for exams like JEE, NEET, and board tests. From ancient tally marks to the binary code powering modern computers, number systems have evolved to meet our needs. We'll start with the basics and gradually build up to more advanced concepts, ensuring you have a solid foundation. Let's begin our journey into the world of numbers and see how they shape everything we do in math. Number system is a structured way to represent and work with numbers. It forms the foundation for all mathematical operations, counting, measuring, comparing, and solving problems. Imagine trying to keep track of quantities without a system. From ancient civilizations using tally marks to today's digital world using binary, number systems have always been essential. In this chapter, we'll focus on mastering the decimal system first, as it's the most commonly used. But don't worry, we'll also touch on binary, octal, and hexadecimal systems, which are vital in computing and technology. Number systems aren't just for mathematicians, they're part of our daily lives. Whether you're counting apples, measuring distances, or programming a computer, you rely on a number system. They help us organize information, perform calculations, and communicate quantities clearly. Without them, solving real-world problems would be chaotic and confusing. Understanding number systems is also crucial for competitive exams, as they form the basis for many mathematical concepts in question. So, mastering number systems gives you a strong advantage in both academics and everyday life. There are several types of number systems, each with its own base and unique uses. The most familiar is the decimal system, which uses base 10 and digits 0, 9. Computers use the binary system base 2, which relies on just 0 and 1. The octal system base 8 and hexadecimal system base 16 are also important, especially in computing and digital electronics. Each system has its own rules for representing and manipulating numbers, making them suitable for different applications. In this guide, we'll focus on the decimal system first, then introduce the others as we progress. Decimal system, also known as base 10, is the number system we use every day. It consists of 10 digits, 0 through 9. Every number you see, whether it's your age, the price of an item, or the distance between two cities, is represented using these digits. The decimal system is powerful because it's easy to use and understand, making it the foundation for most mathematical operations. In this video, we'll master the decimal system before exploring other number systems, ensuring you have a strong grasp of the basics. Understanding number systems isn't just academic. It's a must for competitive exams like JEE, NEET, and board examinations. Many questions test your ability to classify, convert, and manipulate numbers in different systems. Mastering these concepts can give you a significant edge, helping you solve problems faster and more accurately. So as we go through this guide, keep in mind that these skills are not only foundational but also highly practical for your academic success. Numbers aren't just a random collection. They're organized into families based on their properties. This classification helps us understand how different types of numbers relate to each other and how they're used in various mathematical operations. We'll explore this beautiful hierarchy step by step, starting from the most basic numbers and moving up to more complex types. By the end, you'll see how all numbers fit into a logical structure, making math more intuitive and manageable. Start with the most basic family, natural numbers. These are the counting numbers we use every day: 1, 2, 3, and so on. Natural numbers are used for counting objects and start from 1 going up to infinity. They're the foundation of all other number types. Whenever you count apples, books, or steps, you're using natural numbers. Simple yet incredibly powerful, they form the building blocks of mathematics. Whole numbers expand on natural numbers by including 0. So the set becomes 0, 1, 2, 3, and so on. 0 is important because it represents nothing, a concept that's essential in mathematics. Whole numbers are used in situations where you might have none of something, like 0 apples or 0 points. They're just as fundamental as natural numbers and are used in everyday counting and calculation. Integers take things a step further by including negative numbers. Now the set is -2, -1, 0, 1, 2, and so on. Integers are useful for representing situations like debts, temperatures below zero, or elevations below sea level. They allow us to work with both positive and negative quantities, making them essential for a wide range of mathematical problems. Rational numbers are numbers that can be expressed as a fraction pq, where p and q are integers and q is not 0. This includes numbers like 3, 4, 7, 2, and even whole numbers like 5, since 5 can be written as 5, 1. Rational numbers also include terminating decimals like 0.75 and recurring decimals like 0.333. If you can write a number as a simple fraction, it's rational. Rational numbers are those that cannot be written as a simple fraction. Their decimal representation is non-terminating and non-recurring, meaning the digits go on forever without repeating. Famous examples include the square root of 2,1414213, pi 3.141592, and e2.718281. These numbers are essential in higher mathematics and appear in many real-world contexts, from geometry to physics. Real numbers include both rational and irrational numbers. In other words, any number that can be placed on the number line is a real number. This includes whole numbers, fractions, decimals, and even numbers like pi and the square root of 2. Real numbers are the most commonly used set in mathematics, covering everything from simple counting to advanced calculations. Imaginary numbers involve the square root of -1, denoted as I, where I2 equals -1. Examples include 3i minus 5i and 2i, which is the square root of -4. While they might sound strange, imaginary numbers are used in advanced fields like physics, engineering, and signal processing. They help solve equations that have no real solutions, expanding the possibilities of mathematics. Complex numbers combine real and imaginary parts. They're written in the form a plus by, where a is the real part and b is the imaginary part. For example, 3 plus 4i minus 2 plus 7i and even 5, which is 5 plus 0i, are all complex numbers. Every real number is technically a complex number with an imaginary part of 0. Complex numbers are vital in advanced mathematics and engineering. Numbers can also be classified as even or odd. Even numbers are divisible by 2, such as 2, 4, 6, and 8. Odd numbers are not divisible by 2, like 1, 3, 5, and 7. This simple classification has many uses in mathematics, from solving equations to identifying patterns. Recognizing whether a number is even or odd is a basic but important skill. Prime numbers are numbers with exactly two factors, one in themselves. Examples include 2, 3, 5, 7, 11, and 13. Primes are the building blocks of all numbers, as every number can be written as a product of primes. Note that 1 is not considered a prime number as it only has one factor. Understanding primes is crucial for topics like factorization and cryptography. Composite numbers have more than two factors. For example, 4, 6, 8, 9, 10, and 12 are all composite because they can be divided by numbers other than 1 and themselves. Understanding the difference between prime and composite numbers helps in factorization and solving various mathematical problems. Twin primes are pairs of prime numbers that differ by 2, such as 3, 5, 5, 7, 11, 13, and 17, 19. These special pairs are interesting in number theory and have been studied for centuries. Twin primes highlight unique patterns within the set of prime numbers and are a fun topic for exploration. Coprime numbers are pairs of numbers whose highest common factor HCF is 1. For example, 8, 9, 15, 28, and 21, 22 are all coprime pairs. This means they have no common factors other than 1. Coprimes are important in topics like fractions, modular arithmetic, and cryptography. Perfect number is a number whose proper divisors add up to the number itself. For example, 6 is perfect because 1 plus 2 plus 3 equals 6, and 28 is perfect because 1 plus 2 plus 4 plus 7 plus 14 equals 28. Perfect numbers are rare and have fascinated mathematicians for centuries. They're a special category with unique properties. Number line is a visual tool that helps us understand the relationships and distances between numbers. Every real number has a unique position on the number line, with 0 at the center, positive numbers to the right, and negative numbers to the left. This simple representation makes it easy to compare numbers and see their order at a glance. On a number line, larger numbers always lie to the right while smaller numbers are to the left. This makes it easy to compare values. For example, -5 is less than -2, which is less than 0, which is less than 3, and so on. Ordering numbers visually helps us solve inequalities and understand relative sizes quickly. The absolute value of a number is its distance from 0 on the number line, always expressed as a positive value. For example, 5 equals 5, 5 equals 5, and 0 equals. Absolute value is useful for measuring distances and differences regardless of direction. It's a simple but powerful concept in mathematics. To find the distance between two numbers a and b on the number line, simply calculate ab. This formula gives you the positive difference regardless of which number is larger. It's a handy tool for solving problems involving distances, differences, and absolute values. 0 holds a unique place in mathematics. It's neither positive nor negative, but it is considered even. However, 0 is not a natural number, it's a whole number. 0 is essential for representing nothing and acts as the origin on the number line. Its properties make it a cornerstone of modern mathematics. By definition, a prime number must have exactly two distinct factors, 1 and itself. The number 1 only has one factor, so it is not considered a prime. This distinction is important for understanding the structure of numbers and for solving problems involving primes. Among all prime numbers, 2 is unique because it's the only even prime. Every other even number is divisible by 2 and at least one other number, making them composite. This makes 2 a special case in the world of primes and an important exception to remember. Any integer can be written as a fraction with denominator 1, such as n1. This means all integers are rational numbers by definition. Recognizing this helps in classifying numbers and understanding their relationships within the number system. Square root of a perfect square like square root 4 equals 2 is rational. However, the square root of a non-perfect square like square root 2 is irrational. Always check if the number under the root is a perfect square to determine if the result is rational or irrational. This distinction is important for solving root-related problems. When adding or multiplying numbers, certain rules apply. Rational plus rational is always rational. Rational plus irrational is irrational, and rational times irrational is also irrational, unless the rational is 0. Knowing these rules helps you predict the nature of results in calculations. Let's quickly recap the hierarchy. Natural numbers are a subset of whole numbers, which are a subset of integers, which are a subset of rational numbers, which are a subset of real numbers, which are a subset of complex numbers. This logical structure helps you see how all numbers are related and where each type fits in. The number line is a powerful visual tool for ordering numbers and understanding their relationships. It helps you see where numbers fall, compare their sizes, and measure distances. Using the number line makes abstract concepts more concrete and easier to grasp. Remember the special categories: even and odd numbers, prime and composite numbers, coprimes, twin primes, and perfect numbers. Each has unique properties and plays a role in different areas of mathematics. Being familiar with these categories helps you tackle a wide range of problems with confidence. Watch out for common traps. Remember that 0 is even but not a natural number, 1 is not prime, and 2 is the only even prime. Always check if a square root is rational by seeing if it's a perfect square. These small details can make a big difference in exams and problem solving. Now that you've mastered the basics of number systems and their classification, it's time to put your knowledge to the test. Download the PDF notes and formula sheet and try out the 10 practice questions provided. Practicing these concepts will help solidify your understanding and prepare you for any exam or real-world application.